This video will help you factor quadratics. In order to factor quadratics, let's think back to diamond problems. Remember, diamond problems we're multiplying to get the top and we're adding to get the bottom. So in this first example, I multiply to get the top and add to get the bottom. Now, the ones that only have the top and bottom filled in will be very helpful for us in the future to factor quadratics. Now let's think back. One strategy is to list all the factors of the top number. Once I have done that, I can see which pairs of numbers will add to give me -7. So I know it's going to be 1 and -8. The other thing I need to know to help me factor quadratics are generic rectangles. To help us understand generic rectangles, let's first look at algebra tiles. So these algebra tiles are showing x plus 3 times the quantity x plus 2. Notice we have a region of x squared and a region of 1s. These regions, the x's, end up being combined when I write my solution. The same concept holds true when I move to a generic rectangle. Now I'm going to find the area of each piece. Notice when I combine like terms, again my x terms are combined. One other interesting fact about generic rectangles that will help us when factoring quadratics is that if you multiply the diagonals of a generic rectangle, they will always be equal. Maybe you're wondering why this works. Well, let's look at a generic case where we're multiplying a plus b times c plus d. When I multiply out each region and take a look at the diagonals, I end up with the same terms. Now we have enough tools to go ahead and factor a quadratic. So we can start with our generic rectangle. We know our x squareds and our 1s are going to go in the corners of our rectangle. We remember that the diagonal will be equal. So I multiply the diagonal to get the top of the diamond. And I know that the x's are going to add to give me the b term, so I can put that in the bottom. Now I can use my tools for solving a diamond problem. I can list all the factors of the top. I can do that in my head or actually write it out. And then I see which will add to give me the bottom of the diamond. Now I can go ahead and fill those into my rectangle. My next step will be to find the greatest common factor of one column or one row. So I'm going to start with this row. The greatest common factor is 2x. Now all I have to do is say what times 2x gave me 2x squared, which is x. What times 2x gave me 2x, which is 1. What times x gave me 3x, which would be 3. And I can check myself. 3 times 1 is 3, so that works. So I've just factored that quadratic. Let's look at another example. I'm going to start by drawing my generic rectangle. I'm going to put the a and the c terms in the corner of the diagonal, the x squared and the 1s. I remember that if I multiply those, that will give me the top of the diamond. And I remember that my b term will go on the bottom, that they will add to give me 17x. Now, if you'd like to, you can list all the factors. You don't have to write this out. You can think of it in your head, but sometimes students like to list them out so they can look at all of the possible scenarios that will multiply to give us the top. So I see that it's a -60. So if I had a -3x and a positive 20x, that would work. So I'm going to go ahead and put those back into my rectangle. Now I want to find the greatest common factor of a column or a row, I'm just going to start with this row, and I notice that that's 4x. What times 4x gave me 4x squared? X. What times 4x gave me 20x? 5. What times x gave me negative 3x, which would be negative 3. So I've factored it to be 4x minus 3 and x plus 5. Try out this final example to see how well you can factor quadratics.